So the recording has started. Okay, so let's start. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL-PMRF Teaching Assistant for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. So this is a seventh week of problem solving session. So if anyone have any doubt, he or she may ask. Okay, or we will start for the seventh week content. Okay, so like in the previous week, we have discussed about many things like the definition of probability, random variables, discrete distribution, continuous distribution, that is univariate distribution as well. And in the last week, we have discussed about bivariate normal distribution. Okay, so today we will discuss about some properties of different random variables or different distributions, and then the order statistics, sampling distribution in which there is P, F, and chi-square distribution, but we will only discuss chi-square in this week. And then the central limit theorem is also there. Okay, so let's start one by one, and then we will solve some numericals based on these topics. So, okay. Now the first is additive property of binomial distribution. Here we will discuss about like the different kind of properties of different variates. That variate may be binomial, Poisson, gamma, exponential, or some other. Okay. So what is the additive property of binomial distribution? It's like suppose x1 follows binomial n1p. Okay. X2 follows binomial n2p, and xn follows binomial nn. Okay, let me write it like xk follows binomial nkp. Okay, so here you can see the one parameter is common actually, the p, the probability of success is common, and the number of trials is different for different variables. Okay, so in this situation, suppose we define a new random variable that is defined via the summation of these random variables. That is, suppose sk, summation of the k random variables, which is like what? Summation of xi, I from 1 to k. Okay, so this distribution follows binomial again with summation ni parameter, and since the p parameter is common, so it's p. Okay, if x1 follows n1 p1, x2 follows n2 p2, then this is not the case. But if one parameter is common and the other parameter, like the number of trials is n1, n2 corresponding to x1, x2, then the summation also follows the binomial distribution with this parameter. Okay. In a similar manner, we have Poisson variate. Okay. So in Poisson, again, x1 follows Poisson lambda 1. Xk follows Poisson lambda k. Okay. Now the summation sk, which is equal to summation of xi, this also follows the same distribution with the parameter summation of lambda I from 1 to k. Okay. This is not the case for all the random variables. Okay, this may follow some random variable, this kind of property. Okay, now we have one more, like geometric. Okay, so the geometric will be like suppose xi follows geometric distribution with p parameter. Okay, that means x1 follows geometric distribution with p parameter, x2 follows geometric p, xn follows geometric p, or xk follows. So in that situation, again, can anyone tell me which distribution is going to follow like xk? So it is not going to follow like the geometric distribution. Okay, so it follows negative binomial distribution with the p parameter. And since we are dealing with k random variable, and these are independent, okay, always remember xi's are independent actually. Okay, xi's are independent. So k we have considered k independent random variable, so it's k and p. Since we know that in geometric distribution, that means the geometric distribution is used when we got the first success. Okay, when we are dealing with the first success, then there we use geometric distribution. And in negative binomial, we use rth success, rth number of success, 5 number of success, 7 number of success, like this. So here, when we consider geometric random variable, so this is the case. Geometric will follow negative binomial. Okay, the same case. What if x1, x2, xk independent random variables? Okay, and this follows negative binomial distribution. What if this happens? So that means like xi follows negative binomial with two parameters. Suppose we have considered ri and p. Okay, so one parameter is common again, and the another is not common. Okay, now now sk, that is nothing but summation of xi. Okay, this follows. Now, since we are dealing with the negative binomial, so it again follows negative binomial with parameter. Obviously, this is the common, which is p, and this one is summation of ri from 1 to k. Okay, so these are like kind of uh, additive properties of different distribution in discrete case. Also, we have continuous case as well. So, like suppose x1 follows exponential lambda, x2 follows exponential lambda, and xk follows like exponential lambda. Okay, so that means these are identical and independent. Okay, xi's are independent and identically distributed random variable, that is IID actually. Okay, so in that case, our the transformed random variable xk sk, which is nothing but summation of xi, this follows actually this follows gamma distribution. Okay, this not going to follow like exponential distribution with summation lambda or n times or k times lambda. No, this follows gamma distribution with parameter. Since we are dealing with k different random variables, so that is like k with lambda parameter. Okay, so this is the case. So that means exponential distribution is a special kind of gamma distribution from there that has already been discussed in the, I think, fourth or fifth week. Okay, So these are the cases. Now again, suppose xi's are like gamma, ri lambda. So obviously its summation also follows gamma. Okay. The same parameter with lambda. And here, since already gamma, so it's nothing but summation of ri. Okay. So these are like exponential to gamma, gamma to gamma. Okay. There is one more property that has been perhaps discussed in the last week. That is a linear property of normal distribution. That is linearity property. Okay. Linearity property of normal distribution. So what happened in this? Like suppose we have xi follows normal distribution with parameter mu I and sigma I square, where I taken from 1 to suppose k. Okay, x1 follows mu1 sigma 1 square, x2 follows mu2 sigma 2 square, and so on. Okay, now suppose we define a linear combination. Okay, so that means yi is like this: ai xi plus bi. Okay, this is the case. And we take summation from I 1 to n. So suppose we define a random variable y, which is actually here, I need to write y, which is y equal to ai xi plus bi. So y, which is summation of ai xi plus bi. This follows, obviously, since we are discussing about the normal distribution, so it follows normal distribution again with the parameter. Since we are discussing about summation, so it's summation ai xi plus bi. So obviously ai mu I plus bi, because the mean is depend on origin as well as scale. So that means the plus or minus should also be included, and the multiplication or division. So here plus or minus b is location change, change of location or change of origin actually. And ai times mu I is scale, scaling of mu I by ai time. Okay. So this is the mean value. And what is the variance value? So variance value is what? Summation ai square sigma I square. Because we know the variance is independent of change of its origin. Independent of change of origin, but depends on change of scale. And square times actually. So ai square times sigma I square. So this is the linearity property of normal distribution. Okay. That has already been like kind of discussed in the previous week. Now we have some more formulas like variance of summation of xi. Variance of summation of xi, I from 1 to n, suppose we have considered. So since I am not talking about the xi's, whether xi's are independent or not, or dependent. So there is nothing is given. So a general formula is like variance of xi is summation of variance of xi, that is variance of summation of xi equal to summation of variance of xi plus twice of covariance of xi xj, where I is less than j. Less than j, that's why twice is there. Okay, so I is less than the covariance of it. If xi's are independent, then covariance terms will be zero. Then variance of summation of xi equals summation of variance of. Okay. The same case, the similar kind of, not same for covariance. Covariance of summation of xi, summation of yi, I suppose. So this is very simple, like. So these are like summation of Here I need to write MN, summation of covariance of xi and yi. Sorry, yjo. That's yi, I think. Okay. So these are some of the formulas. That means if we know the baseline kind of information, then we can apply those information to find the transform variables, mean variance, or other statistical characteristics as well. Okay. Now we have bivariate uniform distribution as well. Okay. Bivariate uniform distribution. In the previous, we have discovered bivariate normal. So here, bivariate uniform. So bivariate uniform distribution is like, suppose twice of k plus 1. So obviously here, one from 1 to k and x2 from 1 to k, and here it's not k, here it's x actually, and where k is any positive integer. Okay, so this is the case for bivariate uniform distribution. In a similar manner, in the lecture already it is defined bivariate beta distribution, then bivariate gamma distribution. Like, let me write here if you want to. So bivariate beta distribution is like, suppose this is like gamma P1 plus P2 plus P3 divided by gamma P1, gamma P2, gamma P3. In univariate, there is two, P1 and P2, and here, sorry, M and N, or P1 or P2 or something. But here we have three parameters. Okay. Then x to the power P1 minus 1, y to the power P2 minus 1, and then 1 minus x 1 minus x minus y to the power P3 minus 1. So this is bivariate beta distribution. Okay. Here x and y greater than 0, x plus y is less than or equal to 0, and P1, P2, and P3 is greater than 0. Also here, if you will going to calculate the marginal, then you may find the marginal of x is again the beta with parameter P1 and P2 plus P3, and y again the beta P2, P1 plus P3. Here, like P3 is like jointly affecting x as well as y random variable. Okay, so that's why x belongs to P1, y belongs to P2, and then P3 belongs to x and y. Okay, so these are some of the like properties of different kind of distributions. Now there is one more formula or one more topic, that is transformation of random variable. So transformation of random variables, again in the same kind of thing, like x follows some particular distribution d1, then what is the distribution of x square, what is the distribution of 2x, what is the distribution x plus 5 kind of distribution, or e to the power x. So Suppose x is a continuous random variable. I'm discussing about the continuous case only here. So if x is a continuous random variable, and its PDF, the associated PDF is small fx. Okay. Suppose we transform a different random variable y, which is a function of x in such a way. In that case, the PDF of y, the PDF of y, the PDF of y will be like fx x in terms of y. Here x, which is function of y, so x in terms of y. Okay, and then the Jacobian dx upon dy. Okay, this is the case, and this is the expression or formula by which we can calculate the PDF, the distribution of transformed random variable y when this y function, this y function is continuously differentiable, like continuously differentiable, and the second is non-decreasing or non-increasing in nature. Non-decreasing, or that is a transform equation expression or a function is continuously differentiable and non-decreasing or non-increasing in nature, then the transform PDF can be evaluated by the star equation. Okay, we can have one example if you want, like the simple one. Like suppose x is a random variable which follows uniform distribution with parameter 0, 1. Okay, and let's just define a transformed random variable y which is equal to e to the power x. Now we need to find the distribution of y. Okay, so distribution of y, here we are given fx is equal to 1. Okay, so this is the case, and we know that e to the power x is continuously differentiable. That means its differentiation is continuous as well, and obviously non-decreasing or non-increasing in case. That means both the condition is satisfied. Okay, so in the interval 0 to 1, obviously always remember in the interval 0 to 1, because the support of x is 0 to 1. So e to the power x is non-decreasing in nature in 0 to 1. So what we can do, we can directly apply this star expression or formula to find the PDF of e to the power x, that is PDF of y. So before going to solve this, let me write the the range of y as well. So like y equal to e to the power x. Okay, this is our expression or transformed equation. So this implies x equal to log of y. Okay, and here we know that x lies between 0 to 1. Okay, x lies between 0 to 1. So that means what? X lies between 0 to 1. We replace x by log y. So log y 0 to 1. From here, we can take exponent on both sides. So e to the power 0, y e to the power 1. This implies what? 1 y. So this is our range for the transform variable y, or the support for the transform variable y. Okay, so now we can calculate the PDF of e to the power x, that is PDF of y, which is function of x and dx upon dy. Okay, Let me also evaluate dx upon dy. Here x is equal to what? X is equal to log y. So obviously dx upon dy is nothing but 1 by y. Simple. So yes, and function is 1. Here fx is 1. And since fx is 1, there is no x, no variable x involved there. So obviously it's 1 into dx upon dy is 1 by y. So that means what? Gy of y is nothing but 1 by y when y ranges from 1 to. So this is the PDF for the random variable y, which is equal to e to the power x. This is how we proceed to find the PDF for distribution of the transformed random variable. I hope it is okay up to this point. If any doubt, then you people may ask. Okay. So now, yes, there is order statistics as well. Order statistics like suppose x1, x2, xn are random variables, IID random variables. Then in that case, like minimum of xi, that can also be denoted as x within parenthesis 1 or for simplicity y1. Okay, like in a similar manner, maximum of xi is denoted at xn because we have n random samples and can be denoted as xn. Okay, so obviously this implies if we are talking about x7, this is not sorry y7, that is x7, the seventh smallest random sample. Okay, so this is the notation only. Okay, so the distribution of order statistics is like suppose xn will be like n minus 1. Okay, here it is actually yn, not xn. The number is yn, and here obviously f of yn. So this is we can directly solve the distribution of minimum of xi. Distribution of minimum of xi, that is n times of pdf to the power n minus 1 into pdf at that point only. Okay. In the same manner, here we can also write because the number is yn, the maximum order distribution actually. So the maximum order is like what? Okay, I'm sorry. This is the maximum order actually. The above one is the maximum order. This is the maximum order distribution. The minimum order distribution is like x1 n 1 minus f of y1 to the power n minus 1 f of y1. So this is how we calculate the maximum and minimum order statistics, the distribution of maximum order statistics. Okay, so now there is two more concepts, the sampling distribution and central limit theorem. This week contain lots of information actually. Okay, so let's central limit theorem. In short, CLT. Okay, so you people may know probably that already has been discussed. Suppose x1, x2, xn be a sequence of IID random variables with mean mu and variance sigma square. So let me write. Let x1, x2, xn be a sequence of IID random variables, RV random variables with mean mu and variance sigma square, and sigma square must be finite in nature. that is less than infinity, is that means finite. Okay. So now if we define a new random variable, that is nothing but the average, the sample mean, which is defined as 1 by n summation of xi. Okay. Then the limiting distribution of this summation xi, 1 by n summation xi, that is xn, is like here xn, okay, not xn directly, we write like in that manner, the limiting distribution, then the limiting distribution of random variable is like x bar minus mu upon sigma by root n. Okay, this is nothing but the same formula, the same concept of standardization of random variable. Okay, so x bar minus mu upon sigma by root n. This follows normal distribution with mean 0 and variance 1 as n tends to infinity. If we consider n to be sufficiently large, then in that condition, suppose xi follows any kind of distribution, that doesn't matter. It all suppose x1 follows d1 distribution, x2 follows d2 distribution, xn follows dn distribution, and these distribution may be same. Okay, but the summation of xi, that is x bar by n, that is x bar minus mu upon sigma by root n. This must follow normal distribution as n tends to infinity. Okay. So this is the central limit theorem. This is the idea of the central limit theorem. Every distribution, random variable converges to a normal distribution for a sufficiently large n. Okay, so now the last topic is like sampling distribution. Am I audible now? Can anyone confirm? Am I audible or not? So see, the sampling distribution means the distribution of the statistic. Okay, the distribution of statistics is called a sampling distribution. Okay, like distribution of statistic. Here, statistic is function of sample values. Okay, thank you, Rahul. Okay, it's like the distribution of statistics is called sampling distribution. Okay, and also what is an statistic, that has already been discussed. So statistics is like it's like function of sample values. That is, from a random sample, we can construct different kind of function. That is what? That is like a sample mean, sample variance, sample median. So anything that can be like constructed as a functional form of the sample values is statistic, not statistics. Statistics is subject. Here statistic, and for distribution of those statistics then is called the sampling distribution. Okay, and there are t, f, and chi-square sampling distribution. That are those are uh, small sampling distribution. Also, if you are going in further classes, you may find those are small sampling distribution, t, f, and chi-square. Okay, so here we will discuss chi-square only. Okay, so chi-square distribution. Okay, we can either write this or like chi-square like this. Okay, so this is chi-square distribution. So its PDF will be like suppose W or omega, or let's say W. Okay, so it's 1 upon 2 to the power n by 2 gamma n by 2 e to the power minus w by 2 w to the power n by 2 minus 1. Here like w is greater than 0, n is greater than 0. So this is the distribution of chi-square. Okay, this is the chi-square distribution with n degree of freedom. Here the parameter is actually n, which is termed as degree of freedom. Okay, and since it is a distribution, so we need to find the description of the distribution as well, like the mean variance, the skewness, the kurtosis, the MGF, etc. So for a chi-square distribution, actually yes, there is one more thing. Actually, you can find out this is a special case of gamma distribution as well. This is a, let me write, a special case of gamma distribution. Gamma distribution with parameter n by 2 and 1 by 2. Okay, so this is a special case of gamma distribution. Also, its mean value is like what? The expectation of W is what? It's n. And the variance of W is it's 2n. So in chi-square distribution, variance is always greater than mean, and it is exactly twice that of. Okay. So its third order moment, central order moment is like 8n. Obviously, since n is greater than 0, 8n is always greater than 0. So this implies what? Always positively skewed. Okay. Also mu4. So mu4 is like the formula is like mu3 cube upon mu2 square, mu3 square upon mu2 cube, sorry. So that comes out to be 12n n plus 4. Again, we have got it is greater than 0. Okay. So if it is leptocortical. So leptocortical is the peaked kind of curve. It can like it contains peaked kind of curve, not flat or normal. Okay, so these are the description of the chi-square distribution. Okay, there's MGF is also there. Like MGF is 1 minus 2 to the power minus n by 2. Here t is less than half. Okay, so this is the overall description of the sampling distribution, that is chi-square distribution. Okay. So these are the topics that has been covered in week 7. So if anyone have any doubt, he or she may ask. If not, then we will solve some numericals based on these topics. Okay. So let me start with question 1. So the question 1 is like let x1, x2, x3 and x4 be independent random variables. Let x1, x2, x3 and x4 be independent random variables with respective means. The respective means are given 1, 1 by 2, 1 by 3 and 1 by 4. Okay, these are given. Then y which is defined as a minimum of x1, x2, x3, x4. Y this that is defined as minimum of x1, x2, x3 and x4 as an exponential distribution with the mean equal to okay. So our question is like x1, x2, x3 and x4 be independent random variable with respective means. 1, 1 by 2, 1 by 3, 1 by 4. Now, y, a new variable which is defined as minimum of xi as an exponential distribution, then we need to find the mean of this new random variable 1. Okay. So, can anyone know any property related to these? Okay. See, if we have a like property, like if change, so we have like suppose let me write what are given in the question. So we are given expectation of x1 is equal to 1, expectation of x2 equal to 1 by 2, expectation of x equal to 1 by 3, and expectation of x4 equal to 1 by 4. Okay, these are given. And what is the PDF of exponential distribution? So the PDF of exponential distribution will be like lambda e to the power minus lambda x is greater than 0, lambda is greater than 0. Okay, so now, yes, in that case, expectation of x is what? It's 1 by lambda. Okay, so we are given expectation of x1 is 1. So that means lambda 1 value comes out to be 1. So this implies what? X1 follows 1 by 1, that is exp1, that is exponential distribution with parameter 1. Similarly, uh, x2 follows what? It's 1 by 2. 1 by lambda is 1 by 2. That means lambda equal to 2. And similarly, x3 follows exp3 and x4 follows exp4. Okay. So these are like the distribution of the 4 random variables. Now we need to find the distribution of the new random variable y first. Then we can find the mean of that random variable. Okay. So there is one more property actually. If xi follows exponential of lambda I and yeah, it's xi and xi's are independent. Xi's follows exponential lambda I and xi's are independent. Then the minimum of xi follows exponential again, okay, with parameter summation of lambda I. Okay, x1 follows lambda 1, x2 follows lambda 2. In the same manner, x4 follows lambda 4, and xi's are independent. That is already given in our case. So in that condition, the minimum of xi follows this. So according to this rule, so y, which is minimum of x1, x2, x3, x4, this follows exponential. Lambda 1 is 1, lambda 2 is 2, lambda 3 is 3, and lambda 4 is 4. So this implies y follows exponential distribution with parameter 10. And we know that if x or y or any random variable follows exponential distribution with parameter lambda, then obviously expected value of y is 1 by 10 or 0.1. So this is the use of these kind of properties. Any doubt up to this point? Anyone? So let me write another question then. The next question, like test results from an electronic circuit board indicate that, let me write with test result from an electronic circuit board indicate that indicate that 50% of board failures are caused by right? 50% of board failures are caused by assembly defects. 40% are due to electrical components, and 10% are due to mechanical defects. Okay, 50% due of board failure caused by assembly defect, 40% electrical components, and 10% due to mechanical defect. Okay, suppose that 10 boards fail independently. Now the question is, suppose that 10 boards fail independently. Let the random variable x, y, and z denote. Let the random variable x, y, and z denote the number of assembly, electrical, and mechanical defects among the 10 boards. We need to find or calculate the probability, x equal to 5, y equal to 3, and z equal to 2. We need to find this. Okay. So let me repeat the question again. We are given in an electric circuit board, 50% failure occurs due to assembly defect, 40% due to electrical component, and 10% due to mechanical defect. Okay, these are the information we are given. Then we are given, we have 10 boards. The next information is we have 10 boards. Then the next information is these X, Y, and Z are these 10 boards are independently filled. Actually, yes, independent one is there. Okay. Then X is what? Assembly, Y is electrical, and Z is mechanical. So number of defects due to electrical, assembly, and mechanical are given. So we need to find this probability that X is equal to 5, Y equal to 3, and Z equal to. So obviously, since each board failure fall into 3 categories, okay, here we have given some categories. Okay, so if you people have watched the video, you may find that if these kind of question is there, then the distribution that these experiment follow is multinomial distribution. Suppose we have two, then that is binomial. We have more than 2 categories. So it is multinomial distribution. Okay, so that means the distribution is multinomial distribution. Okay, so the distribution is multinomial. So obviously its PDF will be like So here, suppose x1, x2, xk. This follows multinomial distribution. So then in that case, n p1, p2, and up to pk. Suppose we have k random variables, so k plus one parameter is there. Okay. So we have three here now. So let me first write the probability. The probability that x1 equal to x1, x2 equal to x2, xk equal to xk. Okay. So the PDF for this is actually n factorial, x1 factorial, x2 factorial, xk factorial. The same kind of thing as we have like see in binomial. Okay. So then it's p1 to the power x1, p2 to the power x2 multiplied by pk to the power xk. Here, one more thing. Here, like x1 plus x2 plus xk comes out to be n. Okay. Here, the numerator n is nothing but x1 plus x2 plus. So this is the PDF for the multinomial distribution. We have more than two categories. That means the random variables are not in dichotomous in nature. So here we have three. So now putting the values accordingly, we may find the question contain the n equal to 10 actually. X is equal to 5, y equal to 3, z equal to 2. So that is x1, x2, x3. 5 plus 3 plus 2 comes out to be 10. Okay. So that means what? We are given n equal to 10. Okay. So yes, in this question, probability of x equal to 5, y equal to 3, z equal to 2 comes out to be 10 factorial. Then 5, 3, 2. So that means 5 factorial, 3 factorial, 2 factorial. Then P1 to the power x. And P1 is what? P1 is 50%, 40%, and 10% respectively. So that means 50%, then 40%, then 10%. Okay. And P1 to the power x1. So x1 will be like 5. This one is 4. This one is 1. Okay. It's not 1. Na? 5, 3, 2. Na? 5, 4, 1. It's 5, 3, 2. Okay. Now this is nothing but the calculation that can be solved via calculators as well. So 10 factorial comes out to be 3, 6, 2, 8, 8, 0, 0. That is 36 lakh 28,800. 5 factorial 120. 4, 3 factorial 6, 2 factorial 2. 0.5 to the power 5. Obviously, these are quite long terms. Okay, so it comes out to be like 0.03125. 0.4 to the power 3, 0.064, 0.1, 0.1, 0.01. Okay, and we need to solve this and comes out to be 2520. These value, in these value comes out to be some 0.00 something. And after solution, we will get x is equal to 5, y equal to 3, z equal to 2. It comes out to be like what terms? It's 0.050. Okay. So this is how we solve. The first thing that we need to know that which distribution the random variable or the experiment follow. Okay. So here multinomial and the PDF of this, and then it's simply just calculation and nothing. Okay. So any doubt up to this point? Okay. So let us write another question then. The next question is like soft drink cans are filled by an automated filling machine. question is soft drink cans are filled by automated filling machine. Assume that the fill volumes of the cans are independent. Assume that the filled volume of the cans are independent. Normal random variables with the standard deviation 15 mm. Is there anyone who want to say anything? 15 ml. Okay, these are the information is given. I think either someone has forgot to mute or he want to say something. Anyone? Okay, let me mute them first. Okay. So these are the question. Now suppose the probability that the mean of a sample of 100 can. Suppose the probability. Suppose the probability that the mean of a sample of 100. The mean of a sample of 100 cans is below 350 ml is 0.005. Okay, this is the sample mean of 100 cans, and the probability that sample mean is less than 350 ml has the probability 0.005. Okay, this is what the given in the last sentence. Then the question is, what should the mean fill volume be equal to? Then the question is, what should the mean fill volume be equal to? Okay, so just try to read the question first. We are given, let me think. Okay, so we are given like a soft drink is automated filling machine, is filled by automated filling machine. Assume that the filled volume of the cans are independent and normal random variable. The standard deviation is given 15 milliliter. Okay. Now the question is, the mean of a sample of 100 cans is below 350 is this. The probability that the mean of the sample of 100 cans is below 350 has the probability 0.005. Then what is the value of the mean value itself? Okay, so that means we need to find the mu only. Okay, so let me solve the question. Anyone have any doubt that what the question says? Then he or she may ask. Okay, So let me write what are given actually. So our random variable is like the here is given a filled volume. Okay, filled volume of cans. Okay, so it's like filled volume of cans. Okay, these are given, and yes, x follows normal distribution with mean mu, and variance is given like 15 ml actually. That is actually standard deviation. So the variance is 15 square. Okay, so these are given. Also, we are given a random sample of size 100. We are given a random sample of size 100. Okay. Also, we are given the probability that the probability that the mean of a sample of 100. So that means what? X. Probability that X bar is less than 350 has the probability 0.005. These are given. Okay. And this sample value, the sample average or the mean value, X bar that is a mean of sample size 100. Okay. So these are the information we are given. Now we have one more like property of normal distribution that if xi follows normal with mean mu and variance sigma square, then x bar follows again normal with mean the same mu and the variance sigma square by n. N is the size of the sample from where that average value of the sample mean is calculated. Okay. So here in our case, x is considered as like x bar is a sample mean of 100. So that means here x bar follows normal distribution. The mean is not known, so mu. The variance is given 15 square. It's 1.5 square upon 100. So that means x bar follows normal, mean, mu. Variance is like what it can be 0. Okay, so it's like what 15 is 225. Okay, and it's divided 2.25 actually divided by 100. So it's 0.225. Simple. Okay. If there's any calculation mistake, please let me know. So these are the cases. Now we are given one simple thing. Okay. The thing is, we are given probability that x bar is less than 350 has probability 0.005. These are given. Now we know that this kind of situation, when we are dealing with normal distribution, then we use standardization process of the normal variate and then use the normal table. So what we can do, x bar minus mu upon sigma by root 10 actually. Okay, so sigma by root 10 is like 0.15 actually. Okay, am I missing something? It's 15 ml. Okay, then why should I write here 1.5 actually? It's 15 square. So obviously it's not this, it's actually it's actually 2.25. Okay, so that means what? The standard deviation, this is variance actually. The sigma square is 2.25. So sigma is 1.5. So upon 1.5, x bar minus mu upon 1.5 is less than 350 minus mu upon 1.5. And this must be equal to 0.005 because these are given condition. Now, the next thing is probability. This is standardization. Z is less than 350 minus mu upon 1.5 comes out to be 0.005. Okay. So now we need to use our normal table. You go to the normal table and then you will search the probability near to this value 0.005. Okay. Because like here it's phi z, no? Phi z equal to 0.005. So the value of z is what? The value of z here is 350 minus mu upon 1.5. And then when you will see, you may see in the table, you may find that this value, this z value is approximately equal to like minus times of 2.575829. Okay. If you may, you will see, you may find maybe up to 2.2 decimal 5, 2.58 or 2.5758. So this is the case. Now, that means what? That means this value and this 350 minus mu upon 1.5 as equal is equal. Okay. So from there only we can write like what? 350 minus mu upon 1.5 equal to minus 2.575829. Okay. Then you will solve that the mu value is what? 350 minus mu equal to 1.5 minus 2.575829. Then the mu will be like what? 350 plus this can be like 350 actually, and plus this can be 3.8637. Okay, this can be calculated as this, and then mu is equal to 353.8637. So the average value, the population mean comes out to be 153. Okay, so this is how we solve this question. These are the simple question actually that we have already solved in the previous classes based on normal distribution. Any doubt or any question up to this point? You may please ask. No. Okay, then we will solve next question. The next question is a plastic casing for a magnetic disc is composed of two halves. Okay, question is given. A plastic casing for a magnetic disc is composed of two halves. Okay, the thickness of each half is normally distributed. The thickness of each half is normally distributed with a mean of 2 millimeter. Okay, 2 mm, and a standard deviation of 0.1 millimeter. And the two halves are independent. Also, we are given, and the two halves are independent. So these are the condition, like information we are given. Now the question is, what is the probability that the total thickness exceeds 4.3 millimeter? Now the question is, what is the probability that the total thickness exceeds 4.3 millimeter? We need to find the probability that the total thickness is greater than 4.3 when x1 and x2 follows normal with 2, mean 2, and the standard deviation 0.1 mm. Okay, simple question. Okay, so let's solve this. You people also try to solve by yourself and let me know if you people have any problem. So what? Like here, xi is what? Thickness of ith half. Where I equal to 1 and 2. The thickness of first half and thickness of second half. Also, we are given like xi follows normal distribution with mean 2 and standard deviation is 0.1. That means the variance is 0.01 or 0.1 whole square. Okay, these are given condition. Also, we are one more thing given. Also, we are given xi's are independent. So we are given xi's are independent actually. Okay, so these three conditions are given. Now the total thickness. We are discussing about the total thickness. The total thickness obviously the sum of the those two halves actually. So let me say the total thickness is t. So the total thickness which is t is nothing but x1 plus x2. Okay, and total thickness is this. Now we know that since xi's are normally distributed and independent in nature, so this means what? We know that if x1 follows normal mu1 or mu sigma 1 square and x2 follows normal with mu2 and sigma 2 square and x1 and x2 are independent, then in that scenarios x1 plus x2 follows the normal distribution with mean mu1 plus mu2 with mean mu1 plus mu2 and variance sigma 1 square plus sigma 2 square. Because these are independent, so there is no term of covariance term. Okay, so this is the case. Now our T must follows what? T must follows the normal distribution with mu1 plus mu2. And here the mu1 is 2 and mu2 is 2. So 2 plus 2. And the variance is like what? 0.01 actually. So it's 0.01 plus 0.01 comes out to be like normal distribution with parameter mu mean is 4 and variability is 0.02. Okay. So we have now this distribution. Now there is one last information. The total thickness exceeds 4.3. So that means we need to find the probability that T is greater than 4.3. 4.3. Obviously, the normal distribution problem, that means T minus mu T or mu we can say upon sigma T is greater than 4.3 minus mu T is equal to 4 upon sigma t equal to under root of 0.02. So this is what probability that suppose Z is greater than 0.3 upon under root of 0.02 comes out to be 0.141 approximately. Okay, yes, 0.1414 you may say. Now what? we need to solve this, which is the probability of z is greater than like 2.12. Okay, you can observe what is the value, what may the value of this. Okay, so obviously these are the case. This is 0. Z is like it's 1, it's 2, it's something here. It's 2.12. Greater than this is like this probability, which is quite less. If you remember the normal curve, you may find that it is quite less. So obviously, this value comes out to be actually after solving 0.01695. When you see the table, you may find this actually. In the previous class, we have already learned how to see the table. So this is the final answer. If any will have any doubt, your see may ask here. Okay. So this is the probability that the thickness is greater than 4.3 millimeter. Okay, so around less than 2% probability that the thickness is greater than this. Okay, so this is the solution. Any question up to this point? Okay, then let's solve the next question. We are given the joint density function of continuous random variable. We are given the joint density function of continuous random variables x and y is given by x plus y when x lie within 0 to 1, y lie within 0 to 1, and 0 otherwise. Okay, so this is the joint distribution. Now, we are also given a transformed random variable. Let u is defined as x minus y. Okay, and we need to find the variance of the new variable u, which is variance of x minus y. Okay, so this is the question. Anyone know how to proceed? We know we are given the joint distribution. We need to find the variance of u, and variance of u can be calculated only if we know the distribution of u, which is x minus y. Okay, so let's solve this. The first thing is variance of u. So that means variance of x minus y. So we have one formula actually, you know, variance of ax plus by. This is actually what? A square variance of x plus b square variance of y plus twice of ab of covariance of xy. Because I haven't said anything about whether the x and y random variable are independent or not. So that means uh, covariance term is there. Okay. Now, how can we calculate the covariance? Okay. So that means we need variance of x, we need variance of y, and we need covariance of xy. Okay. These three terms we need to find. Because what? Like then variance of x minus y will be log. Will be like a variance of x plus variance of y minus 2 into a into b. So 1 into 1 minus of twice of covariance of xy. We need to find this. So variance of x, for variance of x, we need marginal of x. For variance of y, we need marginal distribution of y. And for covariance, the covariance is also like the formula for the covariance is covariance of xy will be like what? It's expectation of xy minus expectation of x into expectation of y. So that means overall, our first aim is to find the marginal of x and marginal of y. Then from there, expectation of x, then expectation of y, then expectation of xy, then variance of x, then variance of y, then covariance, and at last, putting those value in variance of x minus y expression, we will find the variance of u. Okay, the simple step, but the like the laborious or the tedious task. Okay, so let's start with the marginal of x because we are given the joint is x plus y. So marginal of x. So we know that the marginal of x is what? Integral. If we need to find the marginal of x, then we will differentiate with respect to y. Y. Okay. And this y, the range of y from here as well. Okay. So now what? The range of y is 0 to 1 and x plus y is the fxy value. It's 0 to 1 xy dy. Okay. So it's x integral over dx, sorry, dy is 0 to 1 plus it's 0 to 1 y dy. Okay. So it's x 1 0 to 1 plus y square by 2 0 to 1. So it comes out to be like x plus half. So this comes out to be x plus half. And yes, the range is like what? The range is already given 0 to 1. X lies between 0 to 1. In the same manner, if you solve, you will find in the same manner fy of y is what? Obviously, here x, f of xy, here dx. Again, it's 0 to 1. It's x plus y dx. And then you will find actually it's nothing but y plus half when y lies between 0. Okay, so we have marginal of x and marginal of y. Now expectation of x, obviously expectation of x is what? Integral x into fx of x dx. This is the formula. Now x ranges from 0 to 1, x into its PDF is x plus half dx. So that means what? 0 to 1 x square plus x by 2 dx. Now it's x cubed by 3 plus x square by 4. It's 0 to 1. Okay. Putting the values, it's 1 by 3 plus 1 by 4. So the expected value of x comes out to be, it's 12. It's 7. Okay. We have expected value of x only. Now the next step is to find the expectation of x square. Okay. So again 0 to 1 x square fx dx. Simple. These are just calculation. Okay, these are just calculation. Now it's 0 to 1 x square, it's x plus half. The marginal of x is x plus half. This again the simple calculation x cube plus x square by 2 dx 0 to 1 comes out to be like x to the power 4 plus 4, x to the power 3 plus 6. Okay, x to the power 3 by 3 and by 2 is already there. So it comes out to be 0 to 1. So it's 1 by 4 plus 1 by 6. So expectation of x square comes out to be what? 12. It's 3 plus 2 comes out to be 5 by 12. Okay. So up to this point, is there any problem? Just simple calculation I'm working on. Okay. Now what is variance? Variance of x comes out to be expectation of x square minus expectation of x whole square. Okay. So it's 5 upon 12 minus expectation of x comes out to be 7 by 12. So it's 7 by 12 whole square. It's 5 by 12 minus 49 upon 144. It comes out to be 60 minus 49 upon 144, which is 11 upon 144. This is the variance. This is the variance of x. So variance of x comes out to be 11 upon 144. Yes, in the same manner, we may solve the variance of y. And this is similarly variance of y comes out to be 11 upon 144 because here you can see or you can observe from the PDF only because the PDF is x plus y. X lies between 0 to 1, y lies between 0 to 1. So that is a symmetrical image. Right? So obviously we got the same mean, same variance for x as well as y. So now we have variance of x, variance of y. Okay. Now the next task is to find the expected value of xy. Expected value of xy actually. So this can be evaluated like what? Integral over this. Okay. So it's x plus y. Okay, let me write here plus xy because the expectation of xy is xy. Then the PDF of the joint PDF of xy, which is x plus y. Here dx, here dy. First is dx, then integration of x. Second is dy, the integration of y from 0 to 1, from 0 to 1. Then. So this is the case. Now first start by solving for x, then for y. So it's y from 0 to 1. It's x from 0 to 1. It's not. It's x square y plus xy square dx dy. Okay. So our first aim is to take these. Okay. So it's like 0 to 1 equal to 0 to 1. And then x, then it's x cube y by 3 plus x square y square by 2. It's 0 to 1 dy. Okay. I hope these are like you can understand. X square can integrated as x cube by 3 and y is there. X cube y by 3. X into y square. So x integrated as x square by 2 and y square is also there. Okay, so this is the case. Putting the values, you may find integral over 0 to 1. It's y by 3 plus y square by 2. Okay, now the next step is integrate this. So y is converted to y square by 2 into 3, 6 plus y cube by 2 into 3, 6. 0 to 1 comes out to be 1 by 6 plus 1 by 6. So expected value of xy comes out to be 1 by 3. Okay. Hope this can be simple for you. Okay, just simple calculation. Now the next step is to find covariance between xy, which is expectation of xy minus expectation of x, expectation of y comes out to be 1 by 3 minus expectation of x. Okay, expectation of x is 7 by 12, 7 by 12. Similarly, expectation of y is 7 by 12. So it is 1 by 3 minus 49 by 144. So it's 144, 4, 8 minus 4, 9. So that means what? Covariance of xy comes out to be minus 1 upon 144. Hope up to this point everything is okay. Okay. So now the next is the covariance term is there. We need only the formula now. This formula, variance of x is there, variance of y is there, covariance of xy is there. Okay. So we can solve this. Let me solve this. Okay, I've already solved the final answer. Okay. So now variance of u equal to variance of x plus variance of y minus twice of covariance of xy. So variance of x is 11 upon 144 plus variance of y is equal to 11 upon 144 minus of twice of. Covariance is also minus actually. So minus minus comes out to be plus 2 into 1 upon 144. It comes out to be 11 plus 11 plus 2, 24. 24 upon 144, which can be divided by 24 as well. So comes out to be 1 by 6. So variance of u, which is equal to variance of x minus y, comes out to be 1 by 6. Any doubt in this question or in the above question? You people, please may ask. Okay. Okay, then if no question, then we can solve the next question. Okay, we have 2 or 3 more question actually. The next question is like, suppose that x1, x2 up to xn are random variables such that the variance of each variable are 1. Okay, we are given suppose that x1, x2, xn are random variables such that the variances of each variable are 1. Okay, and correlation between each pair of different variable is 1 by 4. And correlation between each pair of different variables is 1 by 4. Now, variance of summation of xi is now then variance of x1 plus x2 plus xn is. We need to calculate the variance of this when each variable has variance 1 with correlation 1 by 4. The simple question with the simple answer. Okay, we need to just use the formula if you remember. Okay, so what we are given, variance of xi comes out to be 1 for all I belongs to 1 to n. And the correlation coefficients between the two variable xi, xj, suppose is 1 by 4 for all I is not equal to z. Okay, so these two conditions are given. Now we need to find variance of xi. Okay, that the formula that we have already discussed. So variance of summation of xi is nothing but summation of variance of xi, because there is no word of independent variables. Okay, so that means this plus twice of double summation of covariance of xi xj. Okay, this is the formula. Now we need to find the covariance, because and we are given correlation. So the next formula, okay, let me solve this. So summation of variance of xi can be, can anyone tell me? It's summation of 1, which is equal to n, because every random variable has variance equal to, so it comes out to be n. And also the correlation coefficient is what? Covariance between n sigma I sigma j. And since variance is equal to 1, so sigma I, that is standard deviation, also be equal to 1. So overall, the correlation is 1 by 4, comes out to be covariance between xi, xj. So the covariance is also equal to 1 by 4 or 0.25. Simple. So we have covariance, we have variance. So now put in the above expression, we may find variance of summation of xi equal to summation of variance of xi that has been calculated already and comes out to be n plus. Here we need to choose xij. I is less than or equal to j actually. No? So for n random variables, the possible number of pairs is what? N choose 2. NC2, that is combination. Okay. So that is what? That is NC2. NC2 times 1 by 4. Simple. So this is what? This is n plus NC2 n plus 1, no, plus 1, and n minus 1 upon 2 into 1 by 4. So it comes out to be, okay, have I made any mistakes? N minus 1 upon 8 and n plus n minus 1 upon 8. I think up to this point it is okay. There is one more. Twice is multiplied here. No? So obviously it comes out to be 1 by 4. I can write it directly 1 by 4. So it's 4n plus n square minus n upon 4, comes out to be like 3n plus n square by 4, which is again equal to n plus 3 by 4. And this is what our variance of summation of xi. Okay. Since we have not give any like condition, so this is the variance of summation of xi. What if I take, let n equal to 3? Then in that situation, variance of x1 plus x2 plus x3 comes out to be 3. 3 plus 3 divided by 4 comes out to be what? 3 into 9, sorry, not 9, it comes out to be 6 plus 3, 6 upon 4. So it's like what? 9 by 2 or 4.5 is our. So this is the case. You can take the any for any value of n. We have different values of variance because we are given the correlation between the variables are 1 by 4 and every variance for all the random variable is 1. So in that case, this is the case. Okay. So any doubt, any problem up to this point? Okay, so let's solve one more question then. This is a quite like interesting question. Okay. The question is given like the joint distribution of the continuous random variable. The joint distribution of continuous random variables x, x, y, and z is constant over the region x square plus y square is less than or equal to 1 and z lies within 0 to 4. Okay. Now the question is determine marginal probability density function of x. Determine the marginal probability density function of x. Okay, this is the question. Now, okay. Here, we are given actually two conditions. Okay, the first one is this. We are given x square plus y square less than or equal to 1. So this is nothing but a circle of unit radius. No? That is unit circle. Okay, so suppose we have x-axis and there is a unit circle. Okay, you have to visualize circle with unit radius. Okay. Now we are also given z, the third axis. We are given three axes, na? X, Y, and Z height. So obviously we are also given z is 0 to 4. So that means there is a circle in 0 to with a unit radius, and then there is a height. So these are nothing but the overall combination is what? Can anyone tell me? The circle is there and the circle on circle, circle upon circle, and there, the so many circle is there because there is a height in the circle. So this region is known as, can anyone? It's cylinder, no? Cylinder is what? Right circular cylinder is what? The circle and then circle and then circle and then circle. So many circles are on each other. So this is the cylinder. So we are going to imagine a region of cylinder. Okay. Now the next is what? We are also given one thing. The joint CDF, the joint distribution is constant actually. Okay. So that means what? That means we are given fx, y, z is constant c. Okay. So let's use the property of probability, the integration of this C comes out to be 1 over the region X, Y, and Z. Okay, so this is the case. So we are given like what? This is X, this is Y, this is Z, this is C. Okay, and then dx, dy, dz comes out to be 1. This is the simple case. Okay, this is the property of probability function. Now, as we know that it is a circle and dx, dy, dz nothing but the volume. We can also write dv here, no? The volume integral. Okay, so what is the volume of cylinder? Or the volume of cylinder. Okay, leave it. The area of circle, pi r square. R comes out to be 1. So that means pi. Okay. And then height is 4. So pi into 4. So that means what? Pi r square h is the volume for the cylinder. If you remember, if you people may remember, you may find this is circle. Okay. And the height comes out to be like what? 4. And the radius comes out to be like 1. So yes, the unit circle has the area pi r square, pi into 1 that is pi, and the height is 4, and the volume of cylinder comes out to be what? Pi r square h. So that is nothing but 4 pi. The integral comes out to be 4 pi. Okay. So from here, without any calculation, you may find out C into 4 pi comes out to be 1. From here, C comes out to be 1 upon 4 pi. Anyone have any doubt that how I have calculated this? Please let me know so that I can discuss with you. Okay, anyone? If not, then that's a simple. You need to know the mensuration chapter, the volume of cylinder. Volume of cylinder is pi r square h. We are given r equal to 1, h equal to 4. So it comes out to be 4 pi. Okay, so the integral terms comes out to be 4 pi and the constant c is there. So c into 4 pi comes out to be 1. From there, c can be evaluated as 1 upon 4 pi. So this is the case. Okay. If still you don't understand, let me know. So this is our constant term. C comes out to be 1 by 4 pi. Okay. Now the next step is to find the marginal marginal PDF of x. Now we need to find the marginal PDF of x. Okay. Just give me a second. Okay, so we have constructed the this joint CDF. Now the next step is to find the margin CDF. Obviously, marginal PDF of x is like this. Then we are we are going to calculate the marginal PDF. Then that means what? X. So that means we have y, we have z. Okay, here f x y z dy dz. Okay, the first thing this y comes out to be this, and then the dz. Hope this formula is understandable. Okay. Now, the limit of y, what should be the limit of y? This is one more condition because the limit of z is 0 to 4. It is already given. Okay. The limit of y is jointly given like x square plus y square less than equal to 1. Okay. So that means what? So that means x square plus y square less than equal to 1. So from there, y square less than equal to 1 minus x square. Okay, from this point, y is comes out to be 1 minus x square under root, and this is minus times of 1 minus x. The limit of y comes out to be this. Okay, up to this point. And the CDF of the joint PDF of XYZ is nothing but 1 upon 4 pi. So let's put it's 0 to 4, the limit of z. It's like minus under root of 1 minus x square to 1 minus x square. It's 1 by 4 pi and dy dz. Okay, we have put all the values. Now the next step is to again solve this first and then dz term. Okay, now these are simple because there is nothing left. Huh? So 1 upon 4 pi comes out to be there, 0 to 4. Okay, and it comes out to be y with minus 1 upon x square to under root of 1 minus x square and then dz. So obviously the under root of 1 minus x square minus minus comes out to be plus. So it is nothing but 1 upon 4 pi integral over 0 to 4, and it is uh, twice of its under root 1 minus x square dz. Since it is not a function of z, comes out to be like 1 upon 4 pi into 2 upon 2 into like 1 minus x square into z. Now 0 to 4. So overall, what? Overall, what it comes up to be like? It comes up to be 1 upon 4 pi into 2 within bracket 1 minus x square into 4. 4 will be cancelled out. So the overall answer comes out to be, you can see now this 4 can be cancelled out with this one. The rest is written directly. So it's 2 upon pi, it's under root 1 minus x square. This is the PDF. But wait, we have one more thing to write now. What is the support for x? The support for x. As you remember the question, the support, the x square plus y square less than or equal to 1. That means it is a part of a unit circle. So obviously comes out to be 0 to 1. So this is the marginal probability density function for the random variable x when the joint distribution is 1 upon 4 pi with these two conditions. Okay. So hope this question, you people understand this question because it's a like, I personally thought it's a nice question actually. Okay. So if you people have any doubt, anything you want to ask, you may clearly ask. Okay. If not, I have one last question based on memoryless property. So let me write. Okay. The next question or the last question is like, suppose x1, x2 up to x10 are IID random variables. x1, x2, x10 are independent and identically distributed random variables following an exponential distribution. Exponential distribution with the mean 9. With the mean 9. Okay. Now the question is find probability that y is greater than 7 given that y is greater than 4 where y is equal to minimum of x1, x2, x10. Okay. So we need to find the probability that y is greater than 7 given y is greater than 4 when y is defined as minimum of xi and xi follows exponential distribution with mean value 9. We are given these three information. So the first thing is to find the distribution of xi. Then from there, find the distribution of y. And then when we have the distribution of y, from there we can calculate the probability. Okay. And yes, there is one more thing. Since exponential distribution in case of a continuous distribution follows the memoryless property. Okay. So here we can use memoryless property because this is in the similar form. You can remember. Okay. So let's solve this. So we are given like what? We are given xi's are exponentially distributed random variable with parameter supposed because for all IIDs, so that is lambda. Okay. So fx, people have already known it is lambda e to the power minus lambda x, for lambda is greater than 0, x is greater than 0. Okay. So the mean of x is 1 by lambda comes out to be 9 in this question. So from there, the lambda comes out to be 1 by 9. Okay. So the value of lambda is this. So that means psi follows exponential 1 by 9. Clear up to this point? Okay. Now, as we know, as we know already that if xi follows exponential lambda, then minimum of xi follows exponential of n lambda when we have n sample. Okay. So from this property, we have y, which is minimum of x1, x10 follows exponential. Here we are given n equal to 10. You can see. So that is 10 lambda, that is 10 by 9. So what? So y follows exponential 10 by 9. Now the probability y is greater than 7 given y is greater than 4. This can be written as what? Probability as y is greater than 4 plus 3 given y is greater than 4. Probability that y is greater than 3 using memoryless property. Okay. So now the next step is to find this value. Also, this is what? This is 1 minus CDF. Na? You will find 1 minus probability that y is less than or equal to 3. And for exponential distribution, 1 minus e to the power minus lambda x. It comes out e to the power minus lambda x. Let me write it y here instead of lambda x. So lambda y, and sorry, this is y is greater than y na here. So probability that y is greater than 3 comes out to be e to the power minus lambda is 10 by 9 into y is 3. So it is what? E to the power minus 10 by 3, which is e to the power minus 3.33. You will solve this and may find approximately 0.03579. The probability that y is greater than 3 comes out to be this. Is it okay up to this point? Is there any doubt? Anyone have any doubt? Anything he or she want to ask? No? Okay then. If not, then we may conclude our session here. Okay. So thank you everyone for joining. Let me stop the recording.